Hello, let's continue our Sudoku adventure with Circuitous Route by DJV. And yes, it did take me a couple takes to say circuitous correctly. So we do have normal 6x6 Sudoku rules. So in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these blue lines in the grid, one very long blue loop, and then this blue line. And these are region sum lines. So what that means, a region is another name for a box. We call them regions sometimes because you can have irregular regions that don't look like boxes anymore. So it's just more generic to call them regions. But anyway, what you do is you take all of the cells that the line passes through within a specific region and you sum them up. And that sum needs to be the same in every single box for the same line. So this line does not need to have the same sum as this line. But this sum is the same as this single digit. And then like this sum is the same as that sum, is the same as that sum, is the same. You get the idea. So those are the rules. The link's in the description. Highly recommend giving this a try yourself. And I'm going to get started right now. All right, so I noticed that this covers 5 cells. So that means it's at least 15. This also covers 5 cells. This digit could be the same as this. Actually, these digits are the same. They must be the same because if the sum of a box is always the same, right? So basically we have to omit the same single digit from both boxes in order for the sum to be the same. Hopefully that makes sense. One of these is a 1. This covers 4. This covers 4. So our sum, we know our sum is going to be 21 minus whatever green is. So it's somewhere between, what, 15 and 20? If green is high, so basically these 2 digits and these 2 digits sum to green, which is interesting. I have also noticed that this 1 looks at these 2. So these are minimum 2, 3. So this is actually only a 5 or 6. Oh, well, that gives us our answer then. I didn't initially look at this because I was like, oh, 5. But I'm used to 9 Sudoku still, where you can get up to 9. But 5 is actually very restrictive in a 6x6. So this is either, well, let's not even look at this yet because the minimum is 2, 3, which would be 5. So this is 5 or 6. But we just said that these 2 cells sum to green. And so it can't be 6 because green maxes at 6. So this has to be 5 and 1. That places this 1. And we know that these are 6. So that's a great start. So we know these 2 add to 6. So they're either 1, 5, which would have to go this way, or they're 2, 4. We don't know the true answer. But we do know that this is a 2, 3 pair. So this can't be a 2. So this can't be a 4. Because this 1 sees it, it can't be 1, 4. In case that wasn't clear. These add to 6. So this has to be a 1. That's a 2, that's a 4. These add to 6. So it's either going to be, oh, this sees a 1 and a 5. So this is going to be 2 and 4 only. Because the 4 also looks in. And I hope it's just Sudoku from here because the rest, the sums should all work out. So it's cool that we basically did outies. We did the sum of the outies instead of trying to deal with the full sum of what it actually touches. And that made it a lot easier to think about. Okay, I can place 6 in this column. 5's down here somewhere. Come on, there must just be some simple Sudoku. Let's get this triple. So I need a 3, 4, and a 6. I noticed that this can only be 3. 4 and 6, nice. I need a 4 over here. This is a triple. Oops, I used center marks, so corner marks. 3, 4, and 5. So 5 can only go here. 2, 3 pair makes that a 4 and a 3. That's a 4. I think in corner marks. So this 4 goes there. 3 and 5 go down here. And then this should be known then. So 2. Okay. This should be a pair for the box. It's a 5, 6, so we know the order. And then this is 1 and 3. So we know the order. I do want to point out something just because I don't think I've talked about this before, but the only reason this is resolvable is because this region sum line pokes in and doesn't touch this one as well, which is kind of interesting because otherwise the 5 and the 6, when you have them in 2 boxes like this, they would otherwise be ambiguous as 5-6 pairs. But because we have this constraint coming in and touching one of them, but not the other, that adds some asymmetry and allowed us to get this 6 or potentially this 5. Actually, this one poking in probably is the one that did it, now that I think about it. But either way, that's something fun to point out. If you're ever thinking about setting puzzles and you end up with this pattern, you're going to have to either go back so you don't get that pattern, or you're going to have to add a constraint to resolve it. That's not classic Sudoku. All right. This should be finishable. Sorry for that weird tangent, but I hope you guys like tangents. This is a 1. This is a 6. If you want to learn more about like advanced Sudoku stuff, I have a playlist on my channel called the Sudoku Discussion. I can't believe I almost said seduction. That's something else. Yeah, let's finish this puzzle. We go over some sort of advanced Sudoku theory that you may not have seen before if you haven't watched that series. So highly recommend it. It's very, very interesting. But anyway, thank you, DJV. Puzzle took longer because I went on weird tangents, but that was nice and simple once I realized that we have to look at the outies. And actually, the way that you built this really leads you towards that conclusion, where you realize that these two have to be the same, and then you go, oh, wait, but then these outies add to the same, and then all of these do, and then this one actually had to be 1, 2, 3 in order to add to 6. So yeah, very cool. So thanks, DJV. Really enjoyed that puzzle. And of course, if you enjoyed this content, then why not leave a like, subscribe, and a kind comment below.